Hi everyone, welcome to the series Let's Get Solving with Google Cloud, and we are at session number 6 where we are actually finishing up with machine learning part. Okay, so my name is Ajinkya Kolle. I'm a data engineering and machine learning instructor, and because I'm a data engineering and machine learning instructor, I give a lot of examples about machine learning because I know a lot of examples about machine learning. So if you attended my last session, machine learning APIs, I give a lot of companies using different kind of APIs of machine learning, and how do they can leverage and reduce their development time by simply using ready-made APIs. That's what we saw last time. So this time what we are going to see is we are going to see how can machine learning model be built in a really easy to build manner with simple SQL language. So that's what we are going to see now. So this is what our aim is, creating a custom machine learning model in a simplified way. So if you had been following any news, they would have kind of mentioned this sentence a lot. We want to democratize machine learning. We want to democratize machine learning. So data is the new oil was one very common dialogue, and now democratizing machine learning was another common dialogue. What did that mean? It meant we want to make machine learning so easy that the let's say activation energy required to start doing machine learning is very less. Okay, so this in this part where we want to build machine learning in a simplified way, this is what we mean. The democratized part of machine learning is what we are going to focus on. So I had already mentioned there are three types of doing machine learning. One, API, which is the simplest part. Third, the custom model, which is generally the hardest way. That's how it was thought to be before. And in the middle, we have AutoML. Okay, so if you want to actually know in a totally different kinds of machine learning can be done, you should do a lab on APIs, you should do a lab on AutoML, and you should do a lab on custom model with help of TensorFlow. You should do a lab on custom model with help of Kubernetes, Kubeflow, and a lab on custom model with help of maybe scikit-learn, with help of maybe BigQuery ML. So you see there is a lot of comprehensive products on machine learning, and we need to know actually kind of all of them so that we can make an informed choice. Okay, so three different ways, and out of this we have to choose one. So this is what we kind of like have to do, and the simplified way which we are choosing now is with the help of BigQuery ML. Okay, so the Qwiklabs thing we have seen quite a bit, so I don't think we need to reiterate the same stuff again and again and again. All you have to know is like go to this link go.gle/ whatever this link is. Okay, you go there, you simply sign up whichever lab this redirects you to. Okay, you create an account there, you go to that lab, you start that lab, you end that lab, and when you do that, you get a 1 month free access on Qwiklabs to do execute all kinds of labs you might want to do by yourself. Okay, so this is a really great opportunity to try out any kind of lab you might want to do, and just simply execute it for free on Google Cloud. So you have labs, you have lab instructions, you have ability to execute labs, so it's a win-win-win. Okay, so the lab which we are going to see today is how to get started with BigQuery ML. Okay, so I had said, let's say I want to, let's say I have to build a custom furniture for my house. Okay, I can't do that if my house isn't ready. It's the same thing with doing machine learning. I shouldn't actually do that unless my data modernization is complete. Now, if my data is very small data, then it doesn't matter really. Just a SQL database could be more than enough for me to start doing machine learning. But if that is not the case, if my data is big data, then my data modernization will helps me a lot. Okay, so let's say data warehouse is a pretty big thing. It is actually a pretty big thing. The number of different products which can actually be used to build a data warehouse are insanely large. So it could happen that in a company where there are 10 teams who are doing different part of a product or something, they could have a different warehouse implementation they have chosen because they have different requirements and they need something more, some feature more, some feature less. So it could happen that way. And what happens is like it leads to more silos into already siloed work culture. What happens is like, even though we work in a very collaborative manner, but what happens is like every implementation is team specific, and it's like, the cross team collaboration and the, let's say, standardization of how you implement something, it's not that much. Now, if you standardize on BigQuery ML, okay, if you standardize on BigQuery for your data warehouse, what happens is like all the teams, all the projects, their data warehouse is BigQuery. And what happens then is like the ease of use to query, manage, and optimize, or whatever it may be, it's extremely simple. Because BigQuery is such an easy product, Then the BigQuery ML feature kind of like came afterwards. Okay, BigQuery ML tries to give you best of the both worlds, the democratization of machine learning, wherein anybody even with a SQL background can actually start doing machine learning, and that's the amazing part. So machine learning APIs, when we talked about last time, the APIs had a pretty standard problem statement. It was like translation, it was like detecting what is present in an image or something, pretty standard stuff. Now if I want to go beyond that, if I want to have a custom statement, maybe predicting a share price, maybe predicting a movement of a share price, maybe predicting a value of an auction, maybe predicting the probability of a user canceling something. What I really love is like in terms of AI, airline industry was one of the first ones who adopted AI in a really big scale. Okay, if you want to give an example, there is a concept called as overbooking. I just love this concept. So what overbooking is, there is a proper modeling done which kind of like tells you, so for this flight on this day at this time there are 100 tickets. Okay, but with the modeling, what kind of like happens is like they know, okay, out of these 100 tickets, if we sold all of them, on an average, statistically, we are quite sure that around 7 people are going to cancel their tickets. So what happens is you sell 107 tickets. So there are only 100 seats, you sell 107 tickets, that's overbooking. So assuming the cancellation is going to happen, and as long as my pattern prediction is actually quite accurate, I actually make more money. So this overbooking concept is amazing. When IRCTC, a site where you have to spend a lot of time to even log in, booking a ticket is even farther ahead of difficult. So it's like, if you're booking a railway ticket in India, IRCTC is a website we go to. There, when they started actually giving the probability of your ticket being confirmed, that was like a step towards what this concept could have been called as overbooking. So the overbooking concept is pretty amazing. It's kind of like we could predict delays, we could predict the possibility of canceling, we could predict, stuff all this. So whether it is demand, supply, any supply change kind of a thing, anything in those scenarios, it's just mind-blowingly efficient to have a model which can, maybe make a 10% difference in your profit. So that's what custom model is. And for that custom model, let's just take a look at some of the examples. Okay. So there is this website called as Applied AI, and if you simply search Applied AI use cases, it should redirect you to this place. This is different use cases of AI. This is not a completely comprehensive list, by the way. There are a lot more, but just some of the ones which are possible, which you can see online. These are some of the ones which are available here. Okay, so you see it's like some around 26 in marketing, some in sales, customer service, IT operation, data analytics, HR, fintech, healthcare, self-driving cars, and blah blah blah. So just to open your minds. Okay, whether I want to, let's say, predict what's the customer retention, whether I want to predict when a certain thing is going to need repair, whether I want to predict whether this person is likely to buy this car or not, so many things. So this recommendation, this suggestion, if a human is actually kind of like spending his time to develop the expertise and then predict something, we could actually learn from that human or the actions he has taken, and we can actually develop ML model which can do the same thing. If you let me just show you this thing, this video. I have to just open the screen and AI not writer. On YouTube, there is this Nerd Writer one channel. On this Nerd Writer one, this video was actually quite interesting, which talks about AI automation, prediction, and stuff like this. And I don't know where that video has gone. Let me see if I can find it immediately. Otherwise, we'll just let it go. So okay, no, it's like he has so many videos that it's going to be hard to even find that. But what the automation is, how it can be done, how it should be done. So this is what kind of like AI kind of like thing talks about. Here, AI is just the beginning. It is not complete automation. It is more like augmentation of our knowledge. And different use cases, and we find out different use cases, we have different possibilities, we have the data required to build the solution of that use case ready, and we have digitalized that data, and then we want to actually build the solution. So that's when we actually kind of like go towards the AI, simplifying AI part, how do we do that? That's when we do that part here. So the modeling, the custom modeling part is pretty complex. You see, you have different use cases, but the creation of model is very difficult thing. It takes around years or something. If you wanna see, there is this website called as Papers with Code. Here you can say get the latest research, and their implementations are available here. There is another website called as Made with ML, and different stuff which kind of like has been built with help of machine learning. You can find their code or articles or stuff like this. So this is pretty interesting, different projects, different papers, and if you want to check this news, this is a decade of artificial intelligence. This kind of like talks about big breakthroughs which have happened, which have been kind of like very interesting. So from 2010 to 2012, all the stuff kind of like began in 2012 when it was actually proven that AI is possible on a large scale. Until that, maybe people called it a AI winter, second AI winter or something. The increasing volume of data, and cloud computing providing a bigger compute, that kind of like made this very much possible. So imagine it, that was the beginning, and this is kind of like pretty interesting stuff. This article is very interesting. Or you could go to this timeline of machine learning, and in this it will redirect you to all the kind of like big breakthroughs which has happened in machine learning. So pretty interesting stuff. So you see, what we are going to do is like we are going to take one example, and for that one example we are going to solve it with help of BigQuery ML, and this is the lab which we have chosen to do that. Okay, so the lab is getting started with BigQuery ML. Okay, let's just go to that now. So I have opened that lab already, and you already know how to use that. Click on Start Lab, copy paste username and password, log in with those credentials into incognito window, and then start executing. So I'm not going to execute it here. I'm simply going to execute it on my Google Cloud Console. Okay. So what we are going to do here is like we have lots of different data sets. Okay, in BigQuery. So BigQuery is a very popular data warehouse, like we have already mentioned. So we have lots of data sets which are available for free on BigQuery. We are going to take one data set about kind of like a retail thing. Okay, and what retail thing? This is Google Merchandise Store. So next time I go to US, I actually want to buy some stuff. I am very lazy at getting the free merchandise which is generally passed for participating different stuff. I forgot to do that. So next time I go there, I'm gonna buy different t-shirts. So not really hoodies, but ooh, this jacket looks nice, micro fleece. So I'm gonna buy some kind of like t-shirt. So what we have on BigQuery, we actually have data of every kind of like transaction happening on this. Okay, so right now let's say Google, I have not logged in as me, right? Google doesn't know that it's me giving this session to do BigQuery ML recommendation. How do we do that BigQuery ML prediction on Google doesn't know that. Okay, so for now Google is just for Google I am a customer. I am a possible customer for Google. They don't know whether actually I will actually buy it or not. Now let's say if it is kind of like found out that I am on the verge of buying, I just need a small nudge. So maybe a pop-up which comes, ooh, you have a discount for you, or maybe your this thing is waived, the shipping charges or stuff like this. Maybe if this thing is like, okay, this guy is just window shopping, this guy is kind of like in many of the sessions he opens this website and gives the demo. If Google kind of like on the back end they know that, then they'll, okay, this guy is just window shopping, no need to waste our time on that person. So knowing a probability or likelihood or possibility of me doing something, and then that can kind of like we can adapt accordingly. That's the fun part of recommendation, and this is what that lab is. Okay, so in this lab of BigQuery ML, the data, e-commerce data of this Google Merchandise Store, it is actually uploaded onto BigQuery, and we are going to use that to do our prediction and machine learning with help of BigQuery. So I'm scrolling down, and what's the syntax of BigQuery ML? So for that, you can actually simply search this BigQuery documentation. Maybe what I'll do is like, okay, let's just do this thing. Let me short pin this lab. Let me pin this lab. Let me pin this as well. Pin this as well. And pin this. So rest of the stuff. Okay, I think the rest of the stuff might be useful to everybody. So I'm simply creating a one tab no this thing extension. Okay. So if you want to see have list of all the links which I have just mentioned, this is the page whose screenshot you take. If on the right hand side you see this is the QR code. If you simply enter this QR code, you should actually open this one tab link where I have put in all of these links. They might be useful to you. Or if you want a short URL of this thing, let me just create one. Is .gd. It's a URL shortener. Oops, my bad, this website is not fine. So it's like, anyways, take a screenshot and photo of this thing. You should be able to get this links. Anyways, so I'm restoring all of them and I'm going back to the BigQuery ML part, and let's just start executing the lab. So the documentation part, it actually tells you what kind of create model statements are present in BigQuery. In BigQuery, with help of SQL, you can start doing machine learning without any pre-existing much knowledge of ML. You simply have to say a statement like this, create space model, and you have stuff like this, if it does not exist, then either create or replace the model and blah, blah, blah. And you kind of like give the options like this. So you give, okay, what's the model type? Linear regression, logistic regression, or K means these are the three algorithms. We have few alpha ones which will be soon be released, and then we'll have more model types as an input here. Then we also have TensorFlow model which can be imported. So if you want to TensorFlow models on AI Hub, if you simply search AI seed bank, you'll find out lots of custom models of TensorFlow are already available as is. You don't have to code them from scratch. You can simply import that into TensorFlow as well. So it's just amazing what BigQuery allows you to do. You don't have to do all of this thing from scratch yourself. You can start using it directly. So what are the input columns? What's the optimization strategy? Regression, sorry, regularization, not regression. Then different iterations, learning rate, blah, blah, blah. So it's pretty complex. It's pretty comprehensive. And when you execute this, you don't have to do anything more than that. That's it. How it trains in a distributed manner, this thing takes care of it. How it implements, this thing takes care of it. We simply use it. Okay. Tools. For example, if I'm using, let's say, tablet right now, I was just playing this Call of Duty game sometime back, and in this tablet, I don't have to know how this game was developed to play that game. If I don't have to use how this tablet was developed to use the tablet, I don't have to know how this MacBook was developed to use the MacBook. I don't have to know the physics part. I don't have to know the PNP gate, how this the electronics was created, how VLSI etching was done, blah, blah, blah. I don't need to know none of that. I can simply use it. I have to understand it, how to use it, and I can use it very powerfully. This is exactly what machine learning allows us to do. As long as I know how to use it, there are so many use cases which I can use and I can get a lot of business value. I just have to start using it and know it how to use it. That's it. So going back to our lab, we are going to see and create the data set, create BigQuery ML lab. This is the data set which we have to create. Okay. So I'm going to go into my Google Cloud Console, which is here. Go to navigation menu. Where is the BigQuery? BigQuery is here in big data part. I already have created something, so it's fine. Maybe e-commerce, I'll use it as is. And okay, so let me just copy paste the query and let's just start executing this thing. So the query is, oops, query is this. Create or replace, and I have to give the project. So project is, I've given my project ID as the project name, so I'm just copy pasting that. And I have to create, okay, so create or replace model, and this thing is e-commerce. Okay, create or replace model into mystical glass something 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 e-commerce. Option this thing if transactions as label from BigQuery table or GA something table suffix blah blah blah. What is this saying? Data set was not found in location US. Weird. Maybe demos. I think I've not created in a place where BigQuery ML is supported. Okay, let me simply create a new table, create a data set. I create, let's create it here. BQML lab. Okay, BQML lab, this is what I'm going to create. BQML lab. Data location default, 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 create. And then I'm going to copy paste. Oops. Like this. And execute. So in BQML lab, we are going to create this model called a sample model and run. This is reading the data from here, whatever my Google merchandise accessories data warehouse was. There is this query. I'm selecting transactions, where is the device from. So maybe this thing figures out, oh, if some devices actually use, the probability of buying increases something. I don't know what pattern it's going to check. That's why we don't have to know it. We simply have to create ML model which can understand that pattern by itself. That's what we do. Okay. So this figures out it is taking, stage is happening pre-processing. Right now it's 32 seconds or something. BigQuery querying is quite fast, but machine learning kind of like takes in more time. So we have, stuff like this. There are lots of things wherein we have, what are the input label columns. This we can find out here. You see, if I want to give a list of columns which I want to use for machine learning and I don't want to use certain number of columns, I want to use only a limited number of columns out of them, we can do them here. So it's all like this. You see, BigQuery kind of like it's a simple SQL query. Okay. And when we kind of like do it, we actually get an extremely easy way of doing machine learning. So what has happened? Wow, it's been a minute or something. It's still executing. And oh, training is happening right now. You see, machine learning training is happening. And then after we can get, training details of whatever has happened. So let's see, let's wait, what happens. And I've shown you this paper, I've shown this thing, I've shown you how to models. Yes, let's talk about technical depth in machine learning. So there is this very popular paper which talks about difficulties of doing machine learning. It says actual machine learning is a really small part of a big work involved. The rest of the boxes are the big work involved, and their size actually tells you how big they are compared to machine learning modeling. So when we are using BigQuery ML, what happens is lots of stuff is already taken care of. That's how BigQuery was developed, and BigQuery ML kind of like a feature of BigQuery. So it's a data warehouse which uses SQL to do machine learning, and it makes it very easy for us. So the query has executed. If I go to execution details, we can see details like this. Oh, what was my error? Oh, error is like this. If I scroll down, what's the kind of like duration? What is the in what happened in iterations? Can I kind of like go through this model multiple times? Blah 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 blah. Stuff like this. So that is the quick overview of doing machine learning. So in BQML tab, BQML and sample model dataset, and under details, we can find model info. Okay. So I go to BigQuery, I go here, I go to sample model, and here the training details are there, more training detail. So I have graphs which we have seen before. If I go into table, this will give me more duration. So there were 9 iterations which were executed. Out of them, training, evaluation, loss, and learning rate was kind of like this. In the evaluation part, this was the evaluation. So wow, fancy, right? Confusion matrix, ROC curve, all of these fancy stuff you have to do the coding in scikit-learn or in TensorFlow. You might pull your hair if you want to learn to do it from scratch. But when we do it on BigQuery ML, everything is done. A query which takes no more than this much time, this much lines, does machine learning for us. That's the fun part of BigQuery ML. So it simplifies everything we have done. It simplifies our job, and it's just mind blowing. So this was the BigQuery ML part and its power. Okay. Please, I would recommend do this lab as a homework, which actually gives you a taste of how to use TensorFlow to do machine learning. So, I have said that machine learning, if we want to do machine learning, I said using APIs, it's the easiest. Then using AutoML, it's easier, not easiest. Then it's still easy using BigQuery ML, and everything else is hard. So how, if you want to get convinced that it is actually hard doing custom implementation, do this lab. You'll know how difficult it is, and then you will go back to BigQuery ML. You'll use it if we can, it can actually be used, or you'll use AutoML if that works, not BigQuery, or you'll use APIs if that works. So that's how the kind of like decision matrix is. You start from APIs if it works, no, then AutoML, no, then BigQuery ML, no, then, and only then you go for the rest part. So this is how we have kind of like machine learning lab. So we are kind of like to the machine learning part in this, let's get solving with Google Cloud. It's been finished. What comes next is we will be seeing how do we kind of like do web development with help of, let's say, app engine part, and then Kubernetes engine, and how it can be scaled and everything. So stay tuned. Next time onwards, we'll start doing that part. So thanks for listening. Thank you.